I am Nadia. I'm the co-founder of CodeYam, and we're building a software simulator. And so I wanted to start off by saying, like, SPC, this is a room full of builders. And as builders, one of our superpowers is imagining the future that we can create with technology, especially with software. And so I wanted to start us with a question and just challenge you all to think, there are so many amazing innovations and breakthroughs. Why don't we have simulation for software? Why doesn't that exist today? Why don't we have Tony Stark's Jarvis equivalent to help us build and understand and test? I believe that that's the future that's going to help give us superpowers to build software more accurately and more quickly. And so that's the future that we're building at CodeYam. And I'm going to share with you a very early demo of our sort of first software simulator. So we'll dive in. Software simulators are really helpful to review code changes. So in this case, we're looking at a PR in GitHub from my co-founder, Jared. CodeYam has automatically simulated all of the changed files, and we can see front-end and back-end changes, as well as the analysis. So let's go in. And here we can see simulations for all visual changes and library changes. So all front-end and back-end changes, as well as impacted areas of the app. So this is any part of our application that's importing the files that have changed. This is where we'd see if there was an unexpected issue or a bug, something broke, we'd find it faster. Going into the simulation, we can see that there are a number of different data scenarios. These were all generated by default using static analysis and AI. And going into the scenario, we can look at the changes. In this case, it's kind of this invoicing component. And we can actually take this simple component and look at it in context. So all of these simulations are automatically generated. We're generating all of the data as well. And you can navigate up this component hierarchy all the way to the parent page. So in this case, we're at the parent dashboard page, and we can see our invoicing component in situ. Now, this is more than just a screenshot. It's a fully interactive demo. We can see different simulations at the page level. We can go in. We can interact with different components. And we can additionally see this from the point of view of different users and different devices. So we can look at tablet. We can look at mobile. And in this case, the simulator is helping us realize mobile adaptive is pretty broken. And so that's something that we'd want to look at and fix as a team. Now, going into the simulation, you get all of this by default. But since this is a live demo and it's pretty fun to see things live, we can also have full control to edit and create new scenarios. So I'm going to go ahead and edit this scenario. Now, in this case, we're looking at a pretty complex data structure. There's multiple clients that have been generated. They have multiple invoices. So this would be a lot of data for me to make by hand. We'd be here way more than 4 minutes. So instead, I'm going to use the AI to ask it to make some changes. So we'll ask it to add 2 new clients with 4 invoices each. And we're going to go ahead and hit generate. And so this is a live demo. It's going to take a little bit of time to run. So rather than watching the loading spinner and me sweat, we will switch gears and we'll look at what's happening under the hood. So going into this, as I said, there's static code analysis as well as AI happening. There are dozens of API calls. And the reason that this is happening is to help us achieve the proper level of abstraction and to create the data. So this is all going on behind the scenes. It's not a simple wrapper. It is a lot of action, a lot of prompt engineering going into this to help us get the simulation and get all of that data appropriately. So we'll take a look back, and we can see that it's run, and we've got 5 clients, and it looks appropriate. Additionally, I can edit this real time. So like, for example, we see client 5 here. I could change the name if I wanted to, and it'll update in real time. This is invoice number 11. We could change the numbers. And so once I'm happy with this, I can go ahead and save this, and it will get added to my suite of automated tests that will run whenever there's a future change to these files. So with simulation, I'm able to better understand these changes. I'm able to understand their impact. I can test them, and I can demo them and get sort of confident in improving that PR. And so with CodeYam, we're pretty excited about the future. This is a super simple demo. It's the first step towards robust software simulation. And this is something that I'm really excited to push on. And I have 2 asks for you all. One is if you're building software and you want to try this, you care about speed, you care about quality, you want to reduce bugs, please reach out to us. We're onboarding our first partners now. And second is if you're an engineer and this gets you excited and you want to build, you like the idea of creativity, of building kind of the first software simulator, we're also hiring a founding engineer. We're an awesome remote team. We're small but mighty. Come join us. Thanks.
I'm trying to understand what really you're building. Do I get it right that you're building like a tool that generates test suite that integrates with your software and integrates with GitHub pull requests, right? And then
Yeah, what is it?
Is it correct?
Sort of. So really, like, it is kind of like the first software simulator. And so what that means to us is basically making it easier to understand code changes, to be able to test them, to your point, and to be able to demo them. And so what it is in terms of like how you run it is a simple sort of view-only, read-only GitHub application that you connect that analyzes all of the code changes as they come in, as well as sort of gives you a baseline. So what's sort of different is like it's like a playground with no setup that gives you many, many different user scenarios for any given code change, all the way from like the isolated component level up through the interactive sort of application layer.
So this is mostly for the UI UX? Is it like for JavaScript applications?
It works for front-end and back-end changes both. So visual changes are more fun to demo because it's more obvious kind of what you're getting, but it actually works on both ends, yeah.
So any languages that you cover? What are the languages that you cover?
Yeah, good question. I was hoping someone would ask. So right now it's mostly like TypeScript and JavaScript and React frameworks like Next.js and Remix.
Cool, great stuff.
Hi there, very cool demo. If I have a full-fledged app where my database is one place, backend is in one place, and frontend is in one place, not like a monorepo structure, but different places, are you able to work with that as well, and how?
I think so. Like right now, basically, we're interacting with the code rather than the database. So this actually doesn't connect to a database at all. All of the data is being generated through the static code analysis in AI. I feel like for that specific case, like we'd want to learn more about the use case and kind of like, do we want to connect the database? Do we not? A big benefit right now that we've kind of heard is that it is independent from the data layer. So we would have to learn more, but potentially.
All right.
Thank you.